Okay, this lecture is all about introduction to interpolation. I am Dr. Noor Badsha, Associate Professor, University of Engineering and Technology, Shah. Okay, so let's talk about interpolation problem. What do we do basically in interpolation? तो आपके पास जो given data है जो discretely defined होता है for a function y is equal to f of x. Okay, let's suppose we have a function y is equal to f of x. Okay, and you see, right, so if we have y1 basically it is the value of this function at x equal to x1. So we say f of x1 that is equal to y1. Similarly, y2 that would be f of x2, and so on. तो यूजुअली इंटरपोलेशन की ज़रूरत हमें उस वक्त पड़ती है जब ये y इज इक्वल टू एफ ऑफ एक्स जो फंक्शन है वो डिस्क्रीट फॉर्म में डिफाइन होता है, उसकी कोई एक्सप्लिसिट रिप्रेजेंटेशन नहीं होती. हमारे पास इस फॉर्म में भी आ सकते हैं ये वैल्यूज़ जो हैं x1 y1 x2 y2 x3 y3 एंड सो ऑन. बाज़ औक़ात इनको हम टेबुलर फॉर्म में भी लिखते हैं. वी से दीज आर द arguments and these are the entries with y is equal to f of x. So for x equal to x naught or x equal to x1, you'll be having y is equal to y1. For x equal to x2, y is equal to y2 and so on. Okay, so then a procedure or process through which we find value of y for some unknown values of x, for intermediate values of x. This value of x could be anywhere between x1 x2 or x2 x3 and so on. अच्छा, इंटरपोलेशन में ये पॉसिबिलिटी है, दे आर डिफरेंट केसेस जिसमें हमारे पास जो x की वैल्यूज़ हैं दे माइट बी इक्वली स्पेस्ड और दे माइट बी अनइक्वली स्पेस्ड एज वेल. तो इक्वली स्पेस्ड का मतलब होगा कि x2 और x1 का डिफरेंस, x3 और x2 का डिफरेंस एंड सो ऑन, ये सारे के सारे क्या होंगे, सेम होंगे. यानी जो x की वैल्यूज़ हैं दे विल बेसिकली फॉर्मिंग एन अरिथमेटिक प्रोग्रेशन. और अगर अनइक्वली स्पेस्ड हैं तो फिर उसके लिए ये ज़रूरी नहीं है. Okay, so why do we do basically interpolation? What is the purpose of solving interpolation problem? So in this case we have aim to predict a function such that it fits all these points. I mean to say, if you are putting x equal to x1, y should be y is equal to y1, and if you put x equal to x2 here, you'll be getting y is equal to y2 here. So you'll be basically fitting all these points for I equal to 1, 2, 3 and so on. That's the main aim of interpolation. Okay, and f is basically, which is obviously is interpolating function. This is called interpolating function, or it can be called as interpolant for the given data. Okay, additional data might be prescribed, such as slope of interpolant at given points. You can do a lot of things after once you have introduced this function. Some more constraints we can obviously impose on it, such as if you want to have a smooth interpolation, or you want to have a monotonic function, or you want to have a convexity of the function f. So these additional constraints might be imposed as well. Okay, and f could be a function of more than one variable as well, but obviously अभी फ़िलहाल हम क्या कर रहे हैं, we are talking about only one dimensional case. Means to say you will only define values of y for values of x. Now what does it mean? What is the purpose of it? You see, if you have a given function like that, जिसका ये graph है, and what do? We basically take some points here. So if you take 2 points and इसको approximate करना चाहते हैं, तो ये green line जो है ये इसकी approximation है, because 2 points अगर आपके पास हैं तो we can approximate this by simply a linear function or a straight line. Okay, let me play this video for you. Okay, you see, as we increase the points, okay, you see it's a bit faster, and जैसे जैसे हम ये points increase करते जाएंगे, जब आपके पास ये 2 points थे तो हमारे पास जो कर्व आया था वो स्ट्रेट लाइन था. अगर हम कोई भी तीसरा पॉइंट ले लें इस कर्व पे तो इस केस में हमारे पास जो है वो क्वाड्रेटिक आ जाता है एंड सो ऑन। तो जैसे जैसे हम पॉइंट्स को इंक्रीज़ करते जाएंगे आप देख सकते हैं कि जो अप्रॉक्सीमेटेड कर्व है और जो ओरिजिनल एग्जैक्ट कर्व है वो दोनों ऑलमोस्ट, यहाँ पे थोड़ा सा भी रहता है, इफ़ यू इंक्रीज सम मोर पॉइंट्स यू टेक वन पॉइंट हियर तो वो फिर फर्दर क्या कर देगा, इसको ये अप्रॉक्सीमेट कर देगा, सी लाइक दैट। एंड इसी रीडिंग बिटवीन लाइंस ऑफ टेबल, these are the purpose, ठीक है। Differentiating or integrating tabular data, if you have a tabular data and we want to differentiate that, आप उसमें rate of change find करना चाहते हैं, आप उसमें whatever, अगर आपको सपोज करें velocity given है किसी भी पार्टिकल की और आप उसकी पोजीशन या उसका डिस्टेंस टेबल फाइंड करना चाहते हैं कि डिस्क्रीट फॉर्म में होगा, तो उस केस में हम इंटीग्रेट करते हैं। तो इंटीग्रेशन जब आप टेबुलर वैल्यू को करते हैं तो उसके लिए ऑब्वियसली इंटरपोलेशन चाहिए होती है, ओके। And there are this is an easy way to evaluate mathematical functions at different points, and you can basically replace complicated function by simple ones, because usually we do polynomial interpolation। so कोई भी function जो होता है एक्सपोनेंशियल फंक्शन हो सकता है, इट माइट बी ट्राइगोनोमेट्रिक फंक्शन, हाइपरबॉलिक फंक्शंस, तो इन सारे फंक्शन को हम क्या करते हैं, वी रिप्लेस देम बाय सिंपल फंक्शन, पॉलिनोमियल फंक्शंस को हम रिप्लेस कर देते हैं। Okay, so do we have any difference between interpolation and approximation? Okay, so let me tell that. By definition, interpolating functions fits given data point exactly. What does it mean? अगर आपने interpolate किया हुआ है y is equal to f of x को, okay, so let's suppose is the original exact function and we have approximated that by some polynomial. Okay, let's call that p of x. So when you put x equal to x1, it will give you exact value. You see, if p of x1, that should be same as f of x1, that is same as y1. And if you put x equal to 2 here, it will give you exactly y2. If you put x equal to 3 here, it will give you exactly y is equal to y3. Okay, so that's what we mean that by definition interpolating function fits given data points exactly. Mean to say the graph of this polynomial will be passing through all the points. Okay, for example, if we have some points given in the plane, okay, like that. So let's suppose that's one point, this is another point, this is another point for values of x. So if you fit a polynomial, it will be simply, it could be anything, but that will be fitting this data exactly. Mean to say this curve y is equal to p of x will be passing through all the points. Graph of this polynomial function p of x, it will be passing through all these points, okay. Right, the next one is interpolation is inappropriate if data points subject to significant errors. Okay, if the data has some errors, so obviously we say interpolation is not a proper approximation for it. It is usually preferable to smooth the noisy data, for example by least square approximation. Okay, and approximation is also more appropriate for special function libraries. There are many special functions which can be approximated by approximation. Okay, what are the main issues in interpolation? So arbitrarily many functions interpolate given set of data points. Okay, you can have any function, you can have interpolating functions, you can have some trigonometric functions, exponential functions, etc. So what form should interpolating function have? These are some questions, some issues. Okay, how should interpolant behave between data points? Right, it will be satisfied by the data points, but what will be going on when we have the points between two numbers x0 and x1, x1 and x2, x2 and x3, and so on. Okay, then should interpolant inherit properties of data such as monotonicity, convexity or periodicity? Right, अगर एक function में ये properties हैं, मोनोटॉनिक है डेटा, कन्वेक्स है और पीरियाडिक वो फंक्शन है, तो क्या इंटरपोलेशन भी इन ही कंडीशन को सेटिस्फाई करेगी कि नहीं करेगी? ओके, तो आर पैरामीटर्स दैट interpolating function meaningful? Okay, तो जो पैरामीटर्स हमारे पास होते हैं इंटरपोलेटिंग फंक्शन में, उनका कोई मकसद भी होगा कि नहीं होगा, right? And the function and data are plotted, should results be visually pleasing? Okay, so these are some issues in the interpolation. So what are the main interpolant? So choice of function for interpolation based on how easy interpolating function is to work with. Okay, तो इसमें हमें मेनली क्या करना होता है, कुछ पैरामीटर्स को कंप्यूट करना होता है, फाइंड करना होता है, फिर इसके बाद हम एवेलिएट करते हैं उस इंटरपोलेंट को. ओके, एंड देन वी कैन डिफरेंशिएट और इंटीग्रेट दैट इंटरपोलेंट एज वेल. अगर आपको उसमें रेट ऑफ चेंज चाहिए तो आपने इंटरपोलेशन को या इंटरपोलेंट को डिफरेंशिएट करना है. अगर आपको कोई इंटीग्रेशन चाहिए, लाइक आपने एरिया फाइंड करना है, अपने वॉल्यूम को फाइंड करना है, आपने डिस्टेंस फाइंड करना है व्हेन वेलोसिटी इज डाटा इज गिवन, for that purpose we'll be integrating that interpolant. Okay, or we are also evaluating what, evaluating interpolant, because if you are given some data and you are interested to find the value for intermediate values, so we are using interpolation. Now, how well properties of interpolant match properties of data to be fit, right? इस तरह से उस पिछले उसमें हमने बात की थी कि क्या वो प्रॉपर्टीज़ को अपने साथ इनहेरिट कर रहा है कि नहीं कर रहा. अब कितना करेक्ट वो करेगा. हाउ वेल प्रॉपर्टीज ऑफ इंटरपोलेंट मैचेस प्रॉपर्टीज ऑफ डाटा टू बी फिट. यानी स्मूथनेस, अगर डाटा स्मूथ डाटा है तो व्हाट अबाउट द इंटरपोलेंट फंक्शन, क्या वो वाकई वो भी उसी लेवल का वो स्मूथनेस उसकी होगी, क्या वो भी उसी लेवल की मोनोटॉनिक फंक्शन होगी, क्या वो भी उसी लेवल की कन्वेक्स फंक्शन होगी, एंड सो ऑन. ओके, तो आपने एक ऐसा इंटरपोलेंट चूज़ करना होता है जो कि ऑब्वियसली इन प्रॉपर्टीज़ क्या करे, वो आपके इंटरपोलेंट जो है वो एवेल्यूएशन करें, उसको आप डिफ्रेंशिएट भी कर सकें, उसको आप इंटीग्रेट कर सकें, ठीक है, और वो जो डाटा की प्रॉपर्टीज़ हैं वो उनको क्या कर दें, उनको सेटिस्फाई करें, उनको भी फॉलो करें, उनको भी इनहेरिट करें. Okay, so there are some functions we are using for interpolation. So the common ones are polynomials. Most of the cases we talk about polynomials. We do talk about piecewise polynomial as well. We can use trigonometric functions for the interpolation depending upon the nature of the data. We talk about exponential functions as well. We talk about rational functions as well. In most of the cases, we usually consider interpolation by in polynomials or and maybe piecewise polynomials as well, depending upon the nature of the data. Okay, if you have some data in one interval and then we have a jump and then we have a data in another interval, so in that case what do? We usually use piecewise polynomials, right? Right, now the question arises, we usually do a regression as well for estimation of for predicting unknown value of x and y, and we do same thing in interpolation. So what is the difference? What are the main differences in interpolation and regression? So we talk about it here, keeping in mind that we use interpolation in numerical analysis just to numerically approximate the function for prediction of something, whereas regression is usually used in statistical data. Okay, the next difference is what it assume, interpolation assume that points in the data set represent the value of a function accurately. Okay, whereas in regression the values might be inexact in that case, right? Interpolation can assume one value of the independent variable which would be associated with one value of the dependent variable. Okay, the value of y will not be repeating. Mean to say, for one value of x you will be having one value of y, right? Whereas in case of regression the data might be in the form, for one value of x you can have more than one value of y, right? For x equal to 1 you can have 3, for x equal to 1 you can have 4 as well, right? These are the statistical data. Okay, the approximated function should match exactly with all the data points. And that would mean if you put x equal to x1 in the interpolation polynomial or interpolate, it will give you y1. If you put x equal to x2, it will give you what, y2, and so on. Whereas in case of regression, that is not important. If you have a function, a regression function, and you put x equal to x1, so it may or may not be same as y1. If you put x equal to x2, again it may or may not be equal to y2, and so on. So the approximated function does not have to match exactly with the data set points. ये उनके लिए ज़रूरी नहीं है रिग्रेशन लाइन के लिए, जबकि इंटरपोलेशन के लिए क्या होगा वो ज़रूरी होगा। विल बी लुकिंग फॉर अ बेस्ट रिग्रेशन लाइन, जो कि यहाँ पे बेस्ट का वर्ड जो होगा उसका डेटा पॉइंट से कोई ताल्लुक नहीं है, उसका हमारे पास डिस्टेंस होता है कि आपकी जो एस्टिमेटेड वैल्यू है, जो प्रिडिक्टेड वैल्यू है और जो ऑब्जर्व्ड वैल्यू है उनके बीच में जो स्क्वायर डिस्टेंस है या सिंपल डिस्टेंस है वो क्या होना चाहिए, दैट मस्ट बी मिनिमम. Okay, the error of the estimated values is bounded by some specific expression, where the error of the estimated values is bounded on average. यहाँ पे एवरेज पे हम बाउंड कर रहे होते हैं, बिकॉज एवरेज जो होता है वो एस्टिमेटेड वैल्यू और जो प्रिडिक्टेड वैल्यू है और जो ऑब्जर्व्ड वैल्यू है उनका एवरेज सेम होना चाहिए. ओके, यहाँ पे आप किसी भी एक्सप्रेशन के साथ कर सकते हैं. द अप्रॉक्सीमेटेड फंक्शन आर फ्रीक्वेंटली यूज्ड फॉर न्यूमेरिकल डिफरेंशिएशन एंड इंटीग्रेशन, whereas a regression is used for predicting or forecasting of something. Okay, so if you look at the graph of these two at the same point, so इस केस में क्या होगा हमारे पास, अगर आपके पास सपोज करें डाटा जो है वो इस फॉर्म में है, let's suppose for one value of x we have this value, for another one is this one, let's suppose we have this one, we do have this one as well. You see that these values are same. For one value of x we are having two values of y, one is this one and the other one is this one. Okay, so in this case we cannot use interpolation, right? You can go for regression, right? Let's suppose we are having distinct data, then how do we do it? So you see, if you have 4 data points or maybe 5 data points, so the interpolating polynomial must be passing through all these points, right? Whereas for a regression function, it is not important to pass through these points. You can fit this by what? By a straight line as well. You can fit this by something like that. You can fit it by some exponential function वगैरह वगैरह. ठीक है, इसके लिए हर एक पॉइंट से पास होना ज़रूरी नहीं है, जबकि इंटरपोलेशन के लिए क्या है, इसका वहाँ से पास होना ज़रूरी होता है. ओके, now let's talk about application of interpolation in civil engineering. So we can calculate bending moments. Okay, we can use interpolation for calculating the bending moment coefficient for two-way slabs in structural design, right? We can obviously determine external wind pressure coefficient on buildings by using interpolation. We can again use interpolation to find the compressive strength of steel. Okay, it can be used in damage analysis of bridge structure. Okay, like what do we do in damage analysis of bridge structure? The damage analysis based on the model parameters usually need to compare the test data with the computed data by theoretical analysis. Where in bridge structure damage analysis, it is impossible that the sensors are set at every node. That's why this test data need to be extended to every node by using interpolation and whatever. Okay, and in civil engineering you have to deal with a lot of calculations like minimum thickness table in a reinforced concrete structure as well. Whereas in mechanical engineering we can obviously use binomial interpolation to determine the performance, right, characteristics of diesel engine. Okay, we can use that for finding the values of load and deflection in a spring, how much load is being applied and how much that spring is deflected, show deflection. Okay, it can be used for estimation of heat transfer as well, and temperature's value can be found at points where the temperature is unknown. डिफरेंट पोजीशन पे आपको कुछ पोजीशन पे टेम्परेचर नोन है, बास पोजीशन पे उसका टेम्परेचर नोन नहीं है, सो हम उसको इंटरपोलेशन को यूज़ कर सकते हैं कि जो अननोन टेम्परेचर है उनको हम फाइंड कर सकें. ओके, एंड इंटरपोलेशन कैन बी यूज्ड फॉर फाइंडिंग थर्मल एक्सपेंशन and temperature. Again the concept is same. If you apply temperature at some points, you cannot apply temperature at every point, so we apply temperature at some points and we look for the thermal expansion, and then the intermediate points at which we have not applied temperature. So if we apply temperature at those points, how much thermal expansion can occur and vice versa. So in that purpose we are using interpolation. Okay, the use की importance है engineering में obviously, right? In the next video, I'll be talking about some interpolation techniques. How do we do interpolation? यहाँ पे हमने mainly discuss किया, mainly हमारा focus है कि हम interpolation है क्या, interpolation की advantages क्या हैं, उसमें issues क्या हैं, और advantages और interpolation को हम civil engineering में, mechanical engineering में या different engineering field में इसको हम कैसे apply कर रहे हैं. I hope you will enjoy this video. Thank you very much. My last message to you guys is keep environment clean and save water. Goodbye. Thank you very much.